Welcome everyone. Today, we'll explore insulation categories used in oil and gas industries. Insulation is critical for protecting equipment, maintaining efficiency, and ensuring safety. We'll look at different types, their purposes, and best practices. In this session, we'll discuss why insulation matters, classify insulation types, review material selection, installation best practices, common failures, and a real-world case study. Finally, we'll summarize key takeaways. Insulation in oil and gas industries plays a critical role in ensuring operational efficiency, safety, and cost-effectiveness. It helps maintain process temperatures, prevents energy losses, and protects personnel from burns. Insulation also mitigates risks such as condensation, corrosion under insulation, CUI, and fire hazards. Without proper insulation, plants face increased energy consumption, equipment degradation, and safety incidents. In addition, insulation contributes to environmental compliance by reducing greenhouse gas emissions through energy conservation. Understanding the different categories of insulation is essential for engineers and maintenance teams to select the right materials and techniques for specific applications. This presentation will cover, number 1, classification of insulation types, number 2, detailed discussion of thermal, acoustic, personnel protection, fireproofing, weatherproofing, and heat tracing insulation, number 3, material selection criteria, number 4, installation best practices, number 5, common failures and solutions, number 6, a real-world case study, and number 7, summary and recommendations. Each section will include diagrams, examples, and speaker notes to provide a comprehensive understanding of insulation systems in oil and gas facilities. Overview of classification of insulation types. Insulation systems in oil and gas are categorized based on their primary function. Number 1, thermal insulation for controlling heat transfer. Number 2, acoustic insulation for noise reduction. Number 3, personnel protection insulation for safety. Number 4, fireproofing or passive fire protection for critical equipment. Number 5, weatherproofing and cladding for environmental protection. And number 6, heat tracing insulation for maintaining process temperatures. Each category addresses specific operational challenges and requires tailored materials and installation techniques. Understanding these categories ensures proper design and compliance with industry standards. Hot and cold or thermal insulation. Thermal insulation is divided into hot and cold categories. Hot insulation minimizes heat loss from systems operating above ambient temperature, such as steam lines and boilers. Materials like mineral wool, calcium silicate, and ceramic fiber are commonly used for temperatures up to 650 degrees Celsius or higher. Cold insulation prevents heat gain and condensation on chilled or cryogenic systems, such as LNG pipelines and refrigeration units. Materials include polyurethane foam, polyisocyanurate, cellular glass, and phenolic foam, suitable for temperatures as low as -196 degrees Celsius. Proper installation and vapor barriers are critical to prevent moisture ingress and maintain insulation performance. Acoustic insulation, personnel protection. Acoustic insulation reduces noise levels generated by equipment such as compressors, pumps, and turbines. Excessive noise can lead to hearing loss and regulatory noncompliance. Materials like mineral wool combined with acoustic barriers or fiberglass panels are effective in absorbing sound waves. Acoustic insulation is often installed in enclosures or around piping systems in high-noise areas. Design considerations include frequency range, sound transmission class, STC, and durability under process conditions. Personnel protection insulation prevents burns from hot surfaces accessible to workers. This category uses thin layers of insulation or removable blankets on valves, flanges, and exposed piping in walkways. The goal is to keep surface temperatures below safe touch limits, typically under 60 degrees Celsius. Removable insulation systems allow easy maintenance access while ensuring safety compliance. Proper labeling and periodic inspection are essential to maintain effectiveness. Fireproofing or passive fire protection, weatherproofing and cladding. Fireproofing insulation protects critical equipment and structural steel from fire exposure, such as jet fires or pool fires. Materials include cementitious coatings, intumescent paints, and fireproofing boards. These systems are designed to maintain structural integrity and prevent catastrophic failure during emergencies. Fireproofing is mandatory for safety-critical components like emergency shutdown valves and load-bearing structures on offshore platforms. Weatherproofing protects insulation from environmental damage, including rain, UV radiation, and mechanical impact. Cladding materials such as aluminum, stainless steel, or PVC jacketing are installed over insulation to provide a durable barrier. Proper sealing and drainage are essential to prevent water ingress, which can lead to corrosion under insulation, CUI. Weatherproofing is critical for outdoor installations and marine environments. Heat tracing insulation, material selection criteria. Heat tracing insulation is used to maintain process temperatures for fluids that solidify or become viscous at lower temperatures, such as sulfur or heavy oils. Electrical or steam tracing systems are installed beneath insulation layers. Materials must accommodate tracing elements without compromising thermal performance. Proper design ensures uniform heat distribution and prevents overheating or cold spots. Selecting insulation materials requires consideration of operating temperature, environmental conditions, fire safety, mechanical strength, and resistance to moisture. Corrosion under insulation or CUI is a major concern, so materials and cladding systems must minimize water ingress. Compliance with standards such as ASTM, ISO, and API ensures reliability and safety. Cost, availability, and ease of installation also influence material choice. Installation best practices, common failures and solutions, case study, oil-gas plant. Proper installation is critical for insulation performance. Key practices include ensuring tight joints, using vapor barriers for cold insulation, and applying protective cladding for outdoor systems. Regular inspection and maintenance prevent degradation and CUI. Training personnel and following manufacturer guidelines are essential for long-term reliability. Common failures include moisture ingress leading to CUI, insulation damage from mechanical impact, and loss of thermal efficiency due to aging. Solutions involve using high-quality materials, proper sealing, and implementing inspection programs. Advanced techniques like thermal imaging can detect insulation defects early. A case study from an LNG facility illustrates the importance of proper insulation. The plant faced significant energy losses and corrosion issues due to inadequate cold insulation and poor weatherproofing. After implementing polyurethane foam insulation with aluminum cladding and strict installation protocols, energy efficiency improved by 15%, and maintenance costs dropped significantly. This example highlights the value of correct material selection and installation practices. Key takeaways, QA. Insulation in oil and gas industries is essential for safety, efficiency, and compliance. Understanding the categories, thermal, acoustic, personnel protection, fireproofing, weatherproofing, and heat tracing, enables informed decisions. Material selection, proper installation, and maintenance are critical to avoid failures and optimize performance. Implementing best practices ensures operational reliability and cost savings.